Hello and warm greetings to everyone. My name is B. Prasad Goud. I am from Hyderabad, India. I done my masters with mathematics and statistics, and also I am a qualified and a trained teacher. I have got 18 years of experience in this field, and teaching is my passion because I did not come to this field by chance. It was my choice. Right after my qualification, that means after doing my post-graduation and B.Ed, I started teaching. And there was no other profession other than teaching. Now here, and I'm very much specialized in mathematics and physics. In fact, I love both the subjects because what do I like about myself is that I make maths and physics so easy for the students that they'll not have that phobia. I know that few students have that phobia and few are very enthusiastic to learn mathematics, and I can reach up to their level also because I deal with A level as well as O level, that is up to high school as well as senior secondary school. And when it comes to statistics, I can teach up to degree level also. Now let me give you a small demo of a topic. That is, I'll be choosing functions as the topic. Functions. So let us discuss about this. According to me, whenever we learn a chapter, always we should know what that chapter means. Say first, I'll define function for you. Before that, if I take one set of numbers, a set A, and another set of numbers, set B, and here for example I have 2, 5 and 10, then this 2 is mapped to 5 and 5 is mapped to 8 and 10 is mapped to 13. Observe this. I'm just taking one set of elements A and another set of elements B. Okay, and if you observe, there is some relation between A and B. Some relation if you observe. And let me take this one as X, or let me represent this as Y. X and Y. You can observe that there is some relation between X and Y when I'm mapping them. When I'm mapping them, there is a relation. Can you identify the relation? Yes, I can say that all the Y values are mapped in such a way that to these X values, if I add 3, for all these X values, if I add 3, I'm getting the corresponding Y values. So this is a relation between X and Y. Generally, whenever we take two sets and when we talk about the relation between these two, the first set of numbers, we call it as domain. And the second set of numbers, we call it as range. Domain and the range. So I have given you a relation between these two set of numbers where I have taken domain as X and range as Y. And we are getting a relation that Y is equal to X plus 3. This I told it as a relation. But now we are going to discuss about the topic function. What is a function? A function is a relation. So this is the relation. This is a function if it satisfies two conditions. What are those two conditions? That is, here you can observe that this is domain, that is the X values. You can observe that nothing is left out here. Means all the elements of the domain are mapped. So the first condition for a function The first condition, all the elements of the domain should be mapped. This is the first condition. That means you should not have anything left out free. For instance, if I take a set A where I have 2, 5, 10 and I have one more number 19, and I am seeing that 2 is mapped to 5, 5 is mapped to 8, 10 is mapped to 13 and 19 is left out. If a number or if an element in this domain is left out or left unmapped, then this is not a function. This is not at all a function. The second condition, let us assume that 19 is not here. I'll take this 2 and this 2 is mapped to another number 6. 2 is mapped to another number 6. Now, if I ask you, what is the relation between these two? That means to this 2, if I add 3, I'll get 5. 2 plus 3, I'm getting it as 5. And 2 plus 4, I'm getting it as 6. And 5 plus 3, I'm getting it as 8. So here you can see that we don't have any common relation between them, between the domain and the range, between the first set of values and the second set of values. So if any element in the domain has repeated mapping, then it is not a function. So no element in the domain should have repeated mapping. So these are the two conditions. If these two conditions satisfied, then that relation is known as a function. And function generally we represented it with fx, or it can be g of x also, or h of x, with a simple letter and the variable within the bracket. Now here, this is the relation between x and y. But if we had to express this as a function, then how do we express it? We write it like this. A function f of x is defined such that this two dots is such that x maps to x plus 3. X maps to x plus 3. That means here we don't write it as y. We say it is the function f of x such that the function is in such a way that x maps to x plus 3. Means if I take one element x, that will be mapped to x plus 3. In this example, if I take 2, 2 is mapped to 2 plus 3. That is 5. So this is how we write a function. But in short form, we write like this, just directly f of x is equal to x plus 3. Then it is understood that the function is that x is mapping to x plus 3. This is what you have to know, and this is the basic concept of a function. So once again, I'll repeat it. What is a function? A function is a relation between two set of values which has to have these two conditions. That means all the elements in the domain should be mapped. Nothing should be left out. And all the elements, or each and every element, should be mapped only once. It cannot have repeated mapping. Now, let us see some basic functions. Everyone will be thinking that, sir, there are many equations in mathematics. So, but how to solve them, what to do with them. For that, you should know the basic concepts. Means different types of functions. I am going to draw the sketch of these functions. Once I draw the sketch, then you'll know what exactly it is, how will the shape be. First, let me draw the sketches, then we'll decide whether that given sketch is a function or not. Like, if you have anything in the form of y is equal to mx plus c, we get the graph like this. It is a straight line. This is called as a linear equation or a linear function. Now, if you have it as y is equal to minus mx plus c, this is also a linear equation, but since the gradient is negative, you get it in this direction. This is the second one. Next, if you have a quadratic equation like y is equal to x squared, ax squared plus bx plus c, y is equal to x squared, then you get the shape in this way, a U-shaped one. And if you have it y is equal to minus x squared, then you get the sketch in this direction. Then we have many functions, many. Let me give you the examples, and then after that we'll see whether a given sketch is a function or not. So we have got here 1, 2, 3, 4. Coming to the next one, if you have anything like y is equal to x cubed, then it is a curve passing through origin. This is the basic shape. And y is equal to minus x cubed, then the sketch looks in this way. Then if you have y is equal to x cubed plus ax squared plus bx and so on, then it is like a wave. It may or may not pass through origin. Then if you have a sketch in this way, y is equal to e to the power of x. E to the power of x, thus we call it as the exponential function. The exponential function looks like this. And if you have logarithmic function, y is equal to ln x, a logarithmic function, then you get like this. Then after that you have got trigonometric functions. We have got many trigonometric functions like y is equal to sin x. I'm just taking a basic one. It's like a wave once again. Y is equal to sin x. Now we have got equation of a circle also. Like if I have x squared plus y squared is equal to r squared, you get a circle. Now let us see that whether are these all functions. That's my question. And let me take one more also, which the reciprocal function, like if your y is equal to 1 by x, then you get the sketch like this. Let us decide whether all these are functions or not. So what are the two conditions that we had discussed? The two conditions that we had discussed were, for a relation to be called as a function, every element in the domain has to be mapped. That means the x values has to be mapped, and there should not be any repeated mapping. If there is any repeated mapping, then it's not a function. So here we have got the functions, we have got different types of sketches. To decide whether it is a function or not, if we draw a perpendicular line anywhere on any of these graphs, and if it crosses the graph at only one point, then we can say that it is a function. Means for one x value we have got only one y value. Let us decide. Now let me observe this one. Is this a function? Y is equal to x squared. Observe this very carefully. I'm going to draw a line, a perpendicular line. Then you can observe that it is intersecting at only one point. At only one point. Yes, it is intersecting at only one point. Then we can say it is function. And coming to this, you can say that all the positive x values are mapped. Positive x values. All the negative x values are also mapped. And 0 is also mapped. Means x values, when I say x values, that means the domain, you can see that all the x values of the domain are mapped. Nothing is left out. Positive x values, negative x values and 0. Nothing is left out. So it can be called as a function. And when I'm drawing a perpendicular line, it is crossing the curve at only one point. That shows that it has only one mapping. It does not have any repeated mapping. Let me take another example in this. Now coming to this logarithmic function. I'll draw a perpendicular line. Okay, I'm doing it. So it is intersecting at only one point. For certain x value, it is intersecting only at one point. That means you'll get certain y value. So one of the condition is satisfied. That means it has got only one mapping. But let us see whether all the elements are mapped here or not. Observe this. The positive x values, yes, all the positive x values are mapped because you have got some y values for that. But what about the 0 and negative x values? Negative x values and 0 are not mapped. Not mapped because I can say that for instance, if I take negative 3, what is the value of y? We don't get it. Means there are some elements in this function, logarithmic function, which are left out. Like for example, in now here the same thing, minus 3, 1, 4. I can get the value for log of 1, which is 0. Log of 4, which is 0.6. I can get this also, but log of minus 3, I don't get any answer. Log of minus 3 is not available. Means some elements of the domain, means minus 3 is left out. So this is not a function. Similarly, coming to this, see equation of circle, is that a function? Let me draw a perpendicular line. Anywhere you can draw it. When I draw a perpendicular line, then I observe that it is intersecting at two different parts of the curve. Means for one x value, you are getting two y values. Means it has repeated mapping. Hence this is also not a function. Coming to this x cube, you just guess it. Is it a function? Then answer is yes, because if I draw a perpendicular line, I see that it intersects at only one point and all the positive values are mapped, negative values are mapped, 0 is mapped, everything is mapped. Now is this a function? Y is equal to 1 by x. Then you can observe that all the positive values are mapped, negative values are mapped, but 0 is not mapped. 1 by 0 is undefined. Means you don't get a y value for x is equal to 0. Hence that is not a function. But what happens is, generally to make it a function, if you might observe some questions, they say that the question will be like this: f of x is equal to 1 by x where x is not equal to 0. They write it like this: f of x is equal to 1 by x where x is not equal to 0. When they say x is not equal to 0, that means they have made a condition that x does not belong to 0. Means they are considering only the positive and the negative values. Hence it can be a function. Thank you.